We're told that Justine wants to put a deck in the corner of her backyard in the shape of a right triangle. The length of one side of the deck is 7 feet more than the other side. The hypotenuse is 13. Find the lengths of the two sides of the deck. So again, geometric problem, what's our first step? Draw the picture. So we know it's going to be in the shape of a right triangle. So let's draw a right triangle. And we know that the length of one side of the deck is 7 feet more than the other side. So let's add 7 feet. And we know that the hypotenuse is 13 feet. So this is 13 feet. We'll call one side of the deck X. And then we know the length of the other side of the deck is X plus 7. And these would both be feet. We're asked to find the lengths of the two sides of the deck. So how do we do that? Well, we use the Pythagorean theorem. The Pythagorean theorem states that in any right triangle, the length of one of the legs or sides squared plus the length of the other side squared equals the length of the hypotenuse squared. So we just substitute into this formula. So if we let A be x, this ends up being x squared, plus the length of the other side is x plus 7 squared, and then our hypotenuse is 13, so this would be 13 squared. Now we just need to simplify, put into standard form just as we had before, and then use the zero product property and set each factor equal to 0 and solve. And that will give us the lengths of our sides. And then add 7 to whatever we solve for x for the length of the other side. So let's go ahead and simplify this. X squared plus x plus 7 squared is going to be x squared plus 14x. If we wrote that out, x plus 7 times x plus 7, we'd end up with outside being 7x, inside being 7x. That adds to 14x. Plus 7 times 7 is 49. And then 13 squared is 169. Then simplifying, x squared plus x squared is 2x squared plus 14x. And then 169, subtracting that from both sides, that's 49 minus 169. That's going to be minus 120 equals 0. So we've got it in standard form, equal to 0. We can factor out a 2 here from every term. So 2 times x squared plus 7x minus 60 equals 0. And then we'll factor this 2 times two binomials. We know that the leading term in each case is going to be just x because we have x squared. And then we want two numbers that multiply to negative 60 but add to 7. So what could that be? What values can we have that will multiply to 60, negative 60, add to 7? Well, let's look at the factors of 60. So the factors of 60, and we'll look at those in combinations. Well, we'd have 1 and 60. It doesn't matter which one we make negative. And we know that because this is negative, we're subtracting 60 and adding 7x. We know that one of them is going to be negative, x minus. One of them is going to be addition. 1 and 60, that's not going to work. That's not going to yield 7x no matter which one is negative. So then we have 2 and 30. That's not going to work. 30 minus 2 isn't 7. 2 minus 30 isn't 7. So then we have 3 and 20. That combination won't work either. It won't give us 7 no matter which one is negative. We have 4 and 15. We're getting closer. 15 minus 4 is 11, but that's not going to work either. And then we have 5 times 12. Now wait a minute, the difference of those two is 7. And we know that the bigger one is going to be added because we're adding 7x. So this is going to end up being x minus 5 times x plus 12. Now using the zero product property, we have 2 equals 0, but we know that's not true. So then we would have x minus 5 equals 0, which would give us x equals 5, or x plus 12 equals 0, which would give us x equals negative 12. Well, we know length cannot be negative. So that gives us x equals 5. Well, x is the length of one side, so if x is the length of one side, then x plus 7 equals 5 plus 7, which equals 12. So tentatively, the lengths of our two sides are 5 feet and 12 feet. We'll check that really quick. So we have a squared plus b squared equals c squared. We have 5 feet and 12 feet. So we want to know, does 5 squared plus 12 squared, does that equal 13 squared? So 25 plus 144, does that equal 169? And it does. 25 plus 144 is 169, so our solution checks. And that tells us that the length, or the length of one side, the length of one side of the deck is 5 feet, and the other side, the length of the other side is 12 feet. So again, we assigned a variable to the length of one side. Based on the given information, we knew the other side was 7 feet longer, and we were given the length of the hypotenuse of the rectangle, 13 feet. So then we used the Pythagorean theorem. We substituted in our side lengths, both of our legs and our hypotenuse, and then we solved for the variable, and then added the 7 for the length of the other side. The variable itself was the length of one of the sides. And then we checked our solutions to make sure that they did work in a right triangle, in which they did, which verified that the length of one side of the deck is 5 feet, and the length of the other side is 12 feet.